Hey everyone, and welcome. Chemical calculations, they can feel like this massive, impossible puzzle, right? Well, today, we're going to crack that code together. We're going to break down all the concepts piece by piece so you can turn this topic from something you dread into one of your biggest strengths. Let's get into it. Okay, before we jump in, I've got to show you your secret weapon for success. Look, you can't just listen to this stuff. You have to do it. That's where active learning comes in. As we go through each idea, I really want you to pause and practice it over on the MCQ SPM platform. Just scan the QR code or pop over to the website. It's truly the best way to make these skills stick for good. So, what's on the menu today? Here's the plan. We'll start with that super tool I just mentioned. Then we'll build a solid foundation by truly mastering mass and moles. After that, we'll decode the common exam question patterns, learn how to dodge the sneaky traps examiners love to set, and finish up with 3 killer revision hacks to get you that A+. Sound good? Let's go. All right, first things first, we're diving into the absolute bedrock of all chemical calculations, mastering mass and moles. Seriously, if you get this part down, even the trickiest problems start to look, well, easy. This is the core foundation, so let's make sure it's rock solid. So first up, relative atomic mass. What on earth is it? Okay, the textbook definition sounds super complicated, but trust me, the main idea is actually really simple. It all comes down to comparison. All we're doing is asking, how much heavier is this atom compared to our universal yardstick? And that yardstick is just a tiny piece of a carbon-12 atom. But why carbon-12? Why not something else, like hydrogen? Well, it really just comes down to practicality. Carbon-12 is super stable, it's everywhere, and it's a solid, which makes it incredibly easy and reliable to work with in a lab. It's just the perfect no-fuss standard to measure everything else against. And this visual, it's perfect. Honestly, just picture a seesaw. You put one atom of your element, let's say lithium, on one side. Then on the other side, you start stacking up those little carbon-12 units until it balances out perfectly. The number of units it took? That's your relative atomic mass. It's as simple as that. Okay, so building on that idea, we get to molar mass. This is the one we're going to use all the time in our calculations. Now, here's the cool part. The number is exactly the same as the relative mass. The only difference? We slap on some real-world units, grams per mole. This is the magic bridge that connects that tiny invisible atomic world to the one in our lab, where we can actually weigh stuff on a scale. Okay, foundation, check. Now for the fun part, applying this to actual exam questions. And here's the best secret about SPM chemistry. The questions aren't random. Nope. They follow super predictable patterns. Once you learn how to spot these clues, you'll know exactly what to do every single time. Let's kick things off with a total classic. Pattern number 1, finding an unknown's mass. So the setup is this. You get a compound's formula and its total mass, but one of the elements is just labeled X. Your job is to figure out the mass of X. Check this out, a perfect example straight from a past paper. We've got the formula, X2CO3, and the total mass, 138. We already know the mass of carbon and oxygen, right? The only mystery is X. See what's happening here? It's just a simple algebra problem wearing a chemistry costume. So, how do we solve this thing? It's a simple 3-step recipe. First, turn that formula into a math equation. 2 X's plus 1 carbon plus 3 oxygens equals 138. Step 2, just plug in the numbers you already know for carbon and oxygen. And step 3, just do the math and solve for X. It's a clear, logical path every time. And boom, X equals 39. Done. See? Once you spot the pattern, the answer just falls right into place. The trick is just setting up that first equation correctly. All right, on to our second major pattern. And let me tell you, this one is probably the most common calculation you're ever going to see in chemistry. Basically, you're given a balanced equation and an amount of one of your ingredients, and you have to figure out how much stuff you can make. Let's look at this question right here. We're starting with 30 grams of ethane gas, and we need to figure out the volume of carbon dioxide it's going to produce. Notice how the question gives you every single clue you need, the balanced equation, the mass you're starting with, and all the constants. Okay, listen up, because this is a 3-step dance, and you have to do the steps in the right order. No exceptions. Step 1, and this is the most important step of all, you have to convert the mass they give you into moles. Grams are useless here. Moles are everything. Step 2, this is the magic part. Use the mole ratio from that balanced equation. It tells you exactly how much product you get from your reactant. Here, 1 mole of ethane makes 2 moles of CO2. And finally, step 3. Convert the moles of your product into whatever unit the question asks for. In this case, volume.
And there's our answer, 44.8 cubic decimeters. Just burn this into your brain. Mass to moles, use the ratio, then moles back to the final unit. If you can master that flow, you've basically conquered stoichiometry.
Okay, so knowing the patterns is huge, but it's only half the battle. The other half is dodging the traps. Examiners love to set these little tripwires to catch you out. So let's go over the most common ones so you can just breeze right past them and keep all those precious marks. Trap number 1, units. Oh my gosh, so many easy marks are lost right here. The molar volume is always in cubic decimeters, but questions will often try to trick you by giving you the volume in cubic centimeters. Here's the pro tip, and it's dead simple. Before you do anything else, convert your volume to dm cubed. Just divide by 1,000, make that your first reflex. Next up, another classic mistake, ignoring those tiny little subscripts. It's so easy to look at something like CCl4 and just add the mass of carbon and chlorine. But that little 4 is screaming at you. It means there are 4 chlorine atoms. You absolutely have to multiply the mass of chlorine by 4. That tiny number changes everything. And the last big trap, the mole ratio. When you're stressed in an exam, it's so tempting to just assume everything reacts in a nice, simple 1-to-1 ratio. But that's almost never true. Your balanced equation is your best friend. It is your map, it is your guide. Those big numbers out front, the coefficients, they exist for a reason. They give you the exact ratio. Always, always check them. Okay, so we've got the concepts down, we can spot the patterns, and we know what traps to avoid. Now, how do we lock all this in and make sure it's ready to go on exam day? Let's talk about your ultimate study plan. Here are my top 3 hacks to really nail your revision. Number 1, become a pattern master. When you see a question, before you even pick up your calculator, stop and ask, what type of problem is this? Is it a find the unknown problem? Is it stoichiometry? Identifying the pattern gives you an instant roadmap. Number 2, use active recall. I'm telling you, this is a game changer. Just rereading notes doesn't work. You need to test yourself. Using the MCQ SPM app forces your brain to pull the information out, which is how you build strong memories. And number 3, visualize it, especially for experiment-based questions. Take 10 seconds to sketch the equipment like the crucible. Drawing it helps you remember the little details, like why you need to lift the lid. It connects the how to the why. And there you have it. That's our deep dive into SPM chemical calculations. We've gone from the very basics all the way to pro-level revision strategies. You have all the tools, you know all the patterns. So really, there's only one question left. Are you ready to put in the practice and make chemical calculations your strongest skill? I think you are. Go get 'em.